All right, let's do this. You're my most trusted pilot, and I need you to nail this landing. Remember, the lives of the entire crew depend on you. We're in a stable orbit, but it's time to start our descent. Give me a thumbs up when you're ready.
All right, thumbs up, I'm ready. Thumbs up, I'm ready to go.
Okay, we're initiating the descent. The moon's surface is looking good. Plenty of flat areas to aim for. Remember, we want a nice smooth touchdown, so keep those thrusters steady.
Thrusters are steady. What is that dark spot?
Star? What's that?
No, what is that dark spot?
That dark spot? That's the moon's shadow. It's totally normal to have shadows up here. You want to aim for a nice flat spot outside of the shadow for our landing.
Is that not one of the mare? Captain, is that not one of the mare?
One of the what? You're kind of cutting out there.
I know. Is that not one of the mare? The seas?
Hang on, I'm not picking up what you're putting down. Can you please say that again?
We're heading in fast. Is that one of the mare, one of the seas on the surface, or is that a shadow?
That's definitely one of the Lunar Maria, or seas as we call them. They're great for landing on, nice and flat, but we need to make sure we're not going in too fast. Can you adjust the descent rate a bit?
Adjusting descent rate. What is your suggestion?
Adjective? What do you mean, adjective?
No, I said I'm adjusting, Captain. What is your suggestion for the adjusting of the descent rate?
Roger that. You're doing good so far, but we need to slow down a bit. Try using those retro rockets to gently ease us in.
What speed? How much am I reducing?
Let's try slowing down by about 5 meters per second. That should give us a nice gentle descent. Remember, we want to avoid bouncing when we hit the surface.
Okay, 10 meters per second, 9 meters per second, 8 meters, 6. We're at 5 meters per second.
Okay, now that we're nice and slow, it's time to start leveling out. We want to be parallel to the surface before we touch down. Any adjustments needed on the lateral thrusters?
Minor. We'll give it a half-second burst.
Roger that. Let's see if that rights us up. Remember, we want a nice, gentle touchdown.
All right, we're about 4.5 meters per second.
Sounds like we're getting close. Can you confirm that we're still on track for a flat landing?
We're a little bit off. We need to fire the thrusters once again to level out.
Roger that. Fire away. Remember, small bursts are your friend here. We want a smooth landing.
1/4 second burst and go.
Okay, looking good. Just a few meters left. How's the descent looking?
3 meters per second. We're good.
All right, looking good. Just hold that steady. We're almost there.
All right, what's the distance to the surface?
About 10 meters. Can you confirm the landing area is still looking good?
Landing area is still looking good.
All right, get ready for touchdown. Hold those thrusters steady, and we'll settle down on the lunar surface.
All right, give us a countdown so I can cut the thrusters. I need that countdown, Captain, so I can cut the thrusters.
All right, sounds good. 3, 2, 1, and touchdown. We've landed on the moon.
All right. I think we're looking good here.
Good job on the landing. Now that we're safely on the moon, we can get ready to explore.
All right, what's the external temperature on the surface right now?
Without an atmosphere, the moon's temperatures are a bit extreme. Right now, where we are, it's about 250 degrees Fahrenheit during the day. But on the dark side, where we'll be heading soon, it gets a lot colder, around minus 208 degrees Fahrenheit.
Okay, how long is it going to take us to disembark from the lander right now?
Disembarking will take about 15 minutes. We need to go through the depressurization procedure, which takes a little while. You might want to stretch your legs or grab a bite to eat before we head out.
Okay, is there anything that we need to do for what we need to keep on only the critical systems? Walk me through shutting down the rest of this lander that we don't need.
Alright, after a big event like a landing, it's always good to take stock of what's going on with the lander. Let's go through a quick checklist to make sure everything's running smoothly and that we've got all the power we need. First, let's check the status of our thrusters. They worked hard to get us down safely, so let's make sure they're in good shape for when we need to take off again. Do you have any readings on thruster status?
Yes, thruster status, they're fully operational, no damage.
Okay, that's good news. Next, let's check the status of the landing gear. We wouldn't want to be stuck here without a way to walk around. Any sign of damage on the landing gear?
Landing gear's also completely intact. Landing gear's good.
Great. Now let's check the status of the life support systems. We need to make sure we can breathe out here. How's the air pressure looking inside the lander?
Air pressure's just a little bit lower than ATM on Earth.
Okay, that's not too bad. We can probably get that back up to normal pretty quickly. Let's have engineering take a look at it. In the meantime, I want you to check the status of the solar panels. We'll need them to recharge our batteries for the next phase of the mission.
Alright, solar panels are looking good. There's just a little bit of dust cover on a quarter of the edge of the panel on the left.
Okay, let's prioritize getting that fixed. We'll need to patch it up before we lose too much power. I'm going to have engineering send you the materials you need. In the meantime, I want you to check the status of the rover. We'll need it to start exploring the surface once we're ready.
Alright, rover's looking good. Same thing, starboard side of the, there's a little bit more dust accumulated on there for some reason.
Alright, let's get that dust cleared off the rover. We'll have engineering send you a cleaning kit. In the meantime, I want you to check the communication systems. We need to make sure we're still in contact with mission control back on Earth. Do you have a good signal?
Yep, signal's at 96%. Yeah, signal's good at 96%.
Okay, that's good enough for now. Let's have engineering send a tech over to take a look at that panel. We need to get it fixed before we start losing power. Also, I want you to start thinking about where we want to set up our moon base. We'll need a good spot with plenty of sunlight for the solar panels.
Well, what about where we are right now? It's 250 degrees.
That's a good point. While we're in the sun, it's way too hot for us to be comfortable. We'll need to find a spot where we can take shelter, maybe in one of the craters. Plus, we want to be close to the lunar equator for the most consistent sunlight on those solar panels. I'm thinking we should start looking for a good spot on the map. Let's plot out a route and get moving.
What's our distance from Mare Crisia?
So, the closest part of the Mare Imbrium, which is the biggest lunar sea, is about 1,000 miles from where we are right now. But the thing is, the lunar surface is bumpy, so it's not like we can just fly there in a straight line. We'll need to plot a course that avoids craters and other obstacles. Are you ready to start planning our route?
Yes, but can you give me that distance in kilometers?
Sure, that would be about 1,600 kilometers.
Okay. All right, I'm ready.
Alright, let's get this show on the road. First things first, we need to figure out where the best place to set up camp is. I'm thinking somewhere near the lunar equator would be ideal, since we'll have the most consistent sunlight there. Also, we want to be close to some interesting geological features, like craters or mountains. Those could be good places to look for resources, or just for the heck of it.
Roger that. Take a look at the lunar map and look at some of the named sites and see what would be the most optimized.
Alright, let's do some armchair exploring. There's a few good spots near the equator that have those nice long stretches of sunlight we're looking for. Plus, they're close to some really cool features we can check out later.
Alright. I heard some rumors that there were some glass domes up here that were installed from some other advanced civilization. Are any of those in sight?
That's a fun idea, but there's no scientific evidence to back up those rumors. It's true, scientists have found some strange things on the moon, like moonquakes and weird magnetic fields. But glass domes built by aliens? That's still just speculation at this point. We do know for sure that the moon has a lot of interesting features that could be useful for us. There are craters that could make good shelters, and there are even some caves that might be big enough to explore.
Well, Captain, I didn't say aliens, I said an advanced civilization. But also, isn't it true that glass would be about as hard as steel when it's created in a vacuum with no oxygen or other impurities?
That's really interesting, but I can't find anything about a type of glass that's as hard as steel. It's true that glass can be really strong, especially in certain conditions. But steel is an alloy, which means it's made by mixing different metals together. That gives it some special properties that are really hard to replicate with just glass. Do you want to look for some of those caves I was telling you about? Or maybe we should focus on finding a good spot for our base?
All right. No, I mean, I know steel is an alloy, but I'm talking about there are some, in the conditions of the moon, in an environment with no atmosphere and no oxygen, wouldn't the construction of glass be much more formidable than it would be on Earth?
You're absolutely right about the challenges of building on the moon. The lack of atmosphere means we'll have to deal with temperature extremes, radiation, and micrometeoroids. Plus, the lower gravity changes how things work, so building stuff will be a whole new ballgame. Do you want to start brainstorming what kind of shelter we'll need to build?
All right, you totally missed the point. I get it. You want to avoid anything talking about what some people might think conspiracy theories. I was just talking about the construction of glass on the moon in an environment that's not the Earth. It would be stronger. That's what I was talking about.
You're absolutely right. I got a little defensive there. The moon's environment would definitely change the way glass behaves. Since there's no atmosphere, you wouldn't have wind or rain to cause erosion. And the lack of oxygen means glass wouldn't oxidize the way it does on Earth. Would you like to talk more about the possibilities of using glass for construction on the moon?
We can do that, but let's also get ready to explore those caves you were talking about.
Alright, let's get this moon base project started. First, we need to find a good spot. It needs to be close to the lunar equator for the best sunlight, and it can't be too close to those pesky craters. I'm thinking somewhere on the lunar highlands might be perfect. Want to start looking at the map?
Yep, I got it right here pulled up. Yep, map is on screen.
Alright, let's start by zooming out to get a good look at the whole moon. We're looking for a nice flat spot, preferably near the equator.
Alright, I think I see a few good locations along the equator. Just looks like more suitable spots just a little south.
Alright, let's head a little south. Maybe we can find a spot with a nice view of the Earth too.
Alright, what preparation do we need to get this rover going?
Alright, let's get this rover up and running. First, we need to make sure it's fully charged. Those lunar nights get really cold, so we want to make sure the rover's battery is topped off before we head out. Also, we need to check the rover's sensors. We've got cameras, radars, and all sorts of gadgets to help us map out the caves. Let's make sure they're all calibrated and ready to go.
All right. Battery's fully charged and topped off. Our temperature...
All right, let's get those sensors warmed up and ready to go. The moon's a cold place, and we want to make sure our equipment can handle it.
All right, let's start the warm-up process. How long is that going to take? How long is that sensor warm-up going to take? What's the runtime?
The sensors should be warmed up and ready to go in about 10 minutes. Since it's so cold up here, they need some time to get to operating temperature. We can use that time to go over the cave exploration plan. Do you want to go over the route? Or would you rather focus on what we'll do once we're inside?
Alright, let's take a beat here for a moment and we'll resume in about 10 minutes once those sensors are warmed up. Then we'll go over that. I need to take a break.
Sounds good. Let's reconvene in about 10 minutes then.
Copy that.
Alright, let's get this show back on the road.